Hello. All right. So now we're going to get into database design. And we're going to start off with talking about just some basics about single table design. Um, we've already basically covered this, so some of it's going to be review, but there's going to be some new terminology involved. This first new terminology is that a single table represents what we call an entity set. So the idea is that we're going to have a table, we're going to name it books. It's going to contain entities, which are books. Each row is going to be a single entity. So you're going to have a row be a book or a user, okay? So the entities, entity is a fancy word for a thing, okay? It's something. Usually we think of it as some sort of like a noun, but it could be anything that you really could envision as sort of being this whole, such that you're going to end up describing it with the attributes. So attributes are sort of what are the adjectives that describe it, but also not just adjectives, but also like subparts and things. So like users. A user's name is not an adjective. It's something that's important with regard to a user. Just the same way like a user can have an email as well. And, we might have other information about a user. There's all sorts of things about books that we might choose to describe it. We might talk about the number of pages it has. If we're talking about physical books, we could talk about its dimensions. We could talk about word counts and other sorts of information if we wanted to, or if we thought it was important for us in the application that we're actually building. So it's these, we're going to represent this set of things, this set of entities in a table, and we'll call that an entity set. Okay. Now, one thing to note is that our tables must have a primary key. Okay, so every single row in a table must uniquely identify a different entity, a different thing that we're keeping track of. And so there must be some way of doing this. We can make primary keys out of a combination of the columns, or even a single column could be used as the primary key. In some cases, we will have our primary key be a auto-incremented integer. We might not have any suitable columns to use as primary key, and so we'll just decide that each one gets a new unique integer ID, but we must do this. Now, what's neat is that, so besides we have these attributes, so when we design our tables, we want to be really sure that each attribute is atomic. So an atomic attribute is something that's indivisible, or is as small as it should be without us needing to make it any smaller. Okay, we'll talk more about atomic in a little bit, but the big thing here is if we do this right and we follow these rules, we'll have a primary key, so we can get every row uniquely identified, and as long as our attributes are atomic, then we get to get the great first step towards good database design. You can kind of think of this as principles by which to do database design. And the first one is reaching first normal form, okay? And normally we don't talk about first normal form, or there's almost zero emphasis of it in the textbooks. I do like that Head First SQL basically leads us up to, and then you'll have first normal form, because without first normal form, you can't get to second normal form, you can't get to third and fourth, and so on. And so it's the foundation. So this is really important that we understand that, we don't just make tables and feel good, and we're just going to use them as a raw storage device, and we'll figure out how to use it. No, we're going to carefully do this such that our attributes are atomic, and we have primary keys, and we're on the road to success with these entity tables. We will have another thing. This is called, we are learning about entity relationship modeling. Relationships will also have tables. They'll also have primary keys. They may or may not have attributes. So again, they'll be conditioned to having to satisfy also these criteria to be in first normal form, but we won't call them entity sets. So you could I've kind of blended two things together here by saying single tables are entity sets, but what I'm really getting at is the first set and the main set of tables we think about, these are all the entities that we're going to be modeling in our system. And so we're going to have this criteria. We'll talk about certainly relationships, relationship sets, and then how to actually represent them as a table as we go along. All right, so some good things that Head First SQL gives us, and I think I like this as practical advice. You're not going to see this in the database textbook. It's too formal. I think one of the things is that the authors of formal textbooks sometimes forget what it's like to get learning things, and so I find this useful advice. So this is Head First SQL or Head First SQL. The author, she gives these steps for a table design. Okay, or how are we going to go about designing a table? The first one is you go and you ask yourself, what is the single or main thing, not very formal language, main thing this table describes? This is basically what is the entity that we're talking about here? Okay, so I like to think of when I'm thinking about the entities, I usually, again, as I said, I think of them as nouns. I used to think of them as plural nouns. So again, the books, the users, we could have bicycles, cars. It could be an abstract thing as well. But I'm going to think in terms of plural words because I'm talking about a set of things where each row is the thing that I would use the singular form to describe. All right. And it's just getting your mind in the right set for design. But yeah, what is this thing that you want to represent? Okay, and it's not multiple things. In other words, sure, we're going to have an entity set and we're going to have rows, but it's not like we're going to say, I'm storing bicycles and cars in this table. No, then you would need to change it and you would need to be maybe talking about, transportation devices or something like that. In other words, what is it? What is the concept of what it is that you're going to model in this table? And it should be something that you feel is well defined and makes sense to you, because it really, what drives this is this next question is, how will you use this table? So in fact, we don't design databases in the abstract. They come about because we're trying to solve actual problems of people or a business or something like that. We will be talking to people in businesses to try to figure out what their problems are. You also are going to, what do you need to know about this thing? All right. And to get to this whole issue of the primary key, how will you access a single row? This will lead you to think about, do I have a primary key? What will uniquely identify a row in this for me? So you're basically, how am I going to be using it? Oh, I'm going to need to be able to query about, the province that this thing is located in. Okay, maybe I need a province column You know, ooh, it's really going to be really important to be able to talk about the color of this entity because there's a whole bunch of different colors associated with different types of these entities. Well, maybe you're going to need a attribute for color and so forth and so on. And what is it what's the essence that makes one of these things uniquely identified? Okay, so this is all about design and coming up with your attributes. So you've got your thing, your entity. Now what are your attributes? And of those attributes, what are you going to have be your primary key? And again, you can use more than one column, but those columns together, those attributes together, have to be able to uniquely identify a single row. All right. So again, this is from the app that you're to help drive this. You'll ask yourself questions, things like, what are the queries you need to run? I was giving you examples there. Oh, I know I'm going to need to inquire about the color, but there could be even more things like, oh, I need to be able to know, I'm going to have to figure out some way of summing up all of the, transactions. Oh yeah, I'm going to have transactions or I want to know what the average amount of a transaction is. Oh, so I need to know like some dollar. Okay, you're gonna figure out what these things are from the use cases that you're putting your answering. Sort of one of the things here is that also can help you drive this is you want to come up with attributes that make your queries easy to write. Okay. By careful design of your attributes. This in particular will help drive you to atomic attributes. Oh, so if it's going to be really hard for me to write this query, there's a good chance that I probably don't have an atomic attribute here. I have to extract it somehow from this column, or worse, it's some combination of these columns to compute some value. It's like, no, it sounds like a bad idea. You need to come up with some better attributes. All right. So we've thought about what is the thing. So what's the entity? What are the attributes that we want? Do we have a primary key? And then once we've done all that, we look at what we've come up with and we be sure to really ask ourselves, are all your columns atomic? Okay. What this means, one way to think about this to help you get to the biggest mistakes people can make is they have an attribute that represents a list or a set. So there are no lists or sets in your columns. So you don't have so for examples so let's look at an example of non-atomic. This is a bad way to do things. So I make myself I'm going to have some really simple table, some entity set. It's going to be called students. This is a way of writing this that we haven't quite seen yet, but we'll get into it. So this is, we write our table name up here, and then we'll just list our, sorry. I can confuse myself. Rewind, not literally, but just listen. So this is I'm looking at a single column here. Okay, so this is the attribute. And I'm going to make some rows. And there could be other attributes for this table, okay? So I'm going to look at a single attribute, the student's attribute. And let's say for whatever this table is, we find that in here we're storing the data, and we'd store this as some string, Bob, comma, Mary, comma, Fred. And we might have then Amy and Kim. And then we might have Brian and Harish. All right. Who knows? What we have here is we're storing lists. So the students column has a list of names in it. Bad. Bad idea. The only way this could possibly be okay is if you truly were having, let's say, a user who's like in some application and you're like, give us the names of your friends and we'll show them on your web page. And all you're going to do is remember whatever they type. They could write, the supreme commander of the universe here. You don't care. You don't care what they tell you. They could give you comma-separated names or something. That's fine. You would treat it just as a field that you read and you put on the website. That's all you're going to do with it. You're going to treat it in an atomic fashion. You're going to treat it as a whole. You're never going to try to break it apart. But there's a good chance that's not what your intention is. When students design databases and they start doing stuff like this, is they're just like, I don't quite know what else to do. So what I'm going to do is I'm going to have a list of students for each of these entities that I have here. And sure, and then I'm going to, when I bring it in, you've been doing some stuff with database programming from Ruby now, and you're like, what I'm going to do is I'm always going to carefully write them out in this format. And when I read it in, I'll do a string split on commas, and I'll break that into a little array. Wouldn't that be cool? No, it's not. Okay. The problem is while you could manipulate the individual names then within the Ruby program, you can't easily use your database to query by these individual names. You'd end up doing all sorts of these like searches, and that's a mess, and that's a pain. Yeah, you couldn't, it's not easy to count how many friends. Before you know it, what you'll end up doing is you'll be doing all the databases work inside your program, and you'll have a mess. You're going to have all sorts of data problems, and you're basically going to be taking a step back in time. Like before relational databases were invented, that's what you would be doing, is you'd be like, all I need is some good storage. You might as well just use files for heaven's sake. So if you see yourself doing this, this is a real sign that you've gone non-atomic. All right. Another thing that is a good sign that you have violated or trying to have a bad solution to this problem is so this is going to label this as a bad thing to do, is you go and you're splitting across columns. I'm just going to say is not a solution. All right, so do not do the following. So don't be like, oh, I have an idea. What I'm going to do is I'm going to make column student 1. Then I'm going to make another column student 2. I'm going to make another column student 3. Yes, it's absolutely, this is horrible for trying to then eventually write your queries. So what are you going to do if you want to know if, so let's say this is a person, and you want to know if this person has a certain other student. So then you have to write a query that's like, is student 1 equal to this? Is student 2 equal to this? Is student 3 equal to this? Yuck, 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 yuck. Don't do this. All right. So if you see yourself doing this, just stop it. That's not good. All right. So what is atomic again? Well, things are atomic based upon their usage. There's no perfect definition of saying, you can't just look at an attribute and instantly know that it's atomic or not, unless it's just something as simple as an integer usually. And and you're like, that the integer represents itself. It's that value, that's its value. I'm not going to play around with that integer. The integer is not a code that I peel apart or anything, So you could misuse integers, but usually they're probably atomic. But other than that, it's all about how you use them. So how you use the data is whether or not it's atomic or not. So it's based on usage. Okay, so let's take as an example, you're going to store an address, like a mailing address, okay? One way that you could store this is, version 1 we could say is, you got some street, blah, 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 Waterloo, Ontario. Version 2, you might say, no, what I'm going to do is I'm going to have a column street, and I'm going to have a column city, and I'm going to have a column province. And so the street is whatever that is. And my city is Waterloo. And yeah, it's a string as well. I'm just not bothering to. Fine, I'll put it in string quotes, and its province is Ontario. Okay, so we've got one way, which is I just store it as one column address, this long string. Another one where it's broken apart with the street part of the address, the city, and the province. Well, what's the right way to do it? We know we need our attributes to be atomic, but being atomic depends upon how we use them, okay? So this one, if all we do is have this stored and maybe display it, and that's the way we use it. We never try to query parts of it or break it apart or anything. It is atomic. If on the other hand, it's like, no, I need to be able to easily search addresses by the city. Geez, that would mean if it was in this form, it would mean you'd have to always be perfectly clear about how you had formatted this string so that you could somehow extract out and identify where the city was in there. It's always you're going to do all these string operations. It's going to be horrible. That would not be atomic if you needed to query by city. On the other hand, you have this this representation down here. If you needed to query by city, this works great. It's easy. Wherever, you got some table, the city is equal to, I'm maybe searching for Waterloo. Great. I can find all the rows whose city is in Waterloo. That's perfect. Am I going to need to break down city? No, I'd say it's atomic. It's as small as it needs to be. It can't really get any smaller. That's great. Now, so we go, oh, okay, this representation is atomic. Sure, but what if you also needed to break apart, not just, you wanted to extract off the number part of a street address, or you wanted to find out what the apartment number was, and that's all embedded in this string. Well, all suddenly then this column is no longer atomic because our usage requires us to yank stuff out of it to do our queries. That's not what we want. But if all of our need was just to be able to query by city or province, this would have been enough, breaking it apart to make it atomic enough that we could have been happy if that was our usage of it. So it all depends on what your usage is. So if I was to put on an exam, you know, is this atomic? What you're going to have to do is to say, well, how's the person using it? Hopefully the problem would give you a description of its need and its usage so that you could determine whether or not this was an atomic way. Or I might very well give you a problem where I say, for this application, we're going to need to be able to do this, this, and this. Make me out a table with some columns. Be sure that it's in first normal form, and you go, yes, I know. That means I have to be sure that I've got a primary key and that my columns are atomic. Great. And so based upon how I describe the entity would be used, you would then design it so it was appropriately designed. So I like this definition to help you remember this for atomic from Headfirst SQL, which is atomic means or is the smallest pieces of data that can't be or shouldn't be divided. And it's this, so our temptation is to take data and keep chopping it up into smaller and smaller and smaller pieces and declare, I have made it all atomic. But what Headfirst SQL advises you is don't go overboard. If it really shouldn't be divided, you're just going to add complexity to your database where you don't need it to be. So break it up until, based upon how you plan and you know how you're going to need to use your data, that the attributes are atomic, and then stop breaking up the data. All right. So let's write this one more time. That atomic is based on usage and don't break up unless needed. So you need to know how it's going to be used, and this is all part of the design process. Is we need to understand what's the usage of our database going to be? What's this application going to need to do? All right. So now we've covered the basics of this table design. Let's now go over drawing it. So in an entity relationship diagram, this is how to draw an entity set. So this is a more formal way of specifying the aspects of our table than it would be of just listing some names and stuff. It's a useful way of showing it. So we will do it this way. So we'll use these rectangular boxes. We're going to have them in two parts with a row here and then a whole bunch of space here. And what we're going to do, we're going to put up here is the name of the table. All right. And I'm going to advise you to get in the habit of using the plural. And again, this is driven through the convention of Rails. You're going to be doing a lot in Rails. Let's just start adopting their conventions. People can argue back and forth, should databases be singular and plural with table names? Not part of that argument. We're going to go to Rails and we're going to follow their conventions. And they're not a bad set of conventions. So plurals for table names, fine by me. Then down here is where we list our columns or our attributes. So this is the name of the entity set or the table. These will be where we put our columns. And so one of the things that we're also going to note is that we will underline columns used as the primary key. All right, so if I was to fill this in example-wise, see if my green pen works today. So I might put users in here. They'll have an ID that I'm going to give them, which is the primary key. That's how I've underlined it. And then I'll be auto incrementing this most likely, but that's not part of the specification here. That comes later. Then I'll also have a column email, and I'll let them use their name. Now, you might say, well, the email should be unique. Why won't I let my users have the email be the primary key? Remember, one of the important rules of a primary key is that it shouldn't change. So once we've identified this specific entity, this specific thing, we want that identifier to stay that for the life of that entity. So if I have a user and I have them identify themselves via their email, I'd basically be saying, and you can never change that person's email. But we know people do change their emails, so that's not a good thing. We also know names are not unique. So, you might think Mark Smucker is a rare name, but there are other people with the name. So, we definitely can't use names, and I might change it. I don't plan to, but I might. Maybe I want to spell things differently or use an abbreviation or some initials. Change my mind. So that's not good. So this is an example certainly where an integer ID that can stay with that user for its lifetime is really the way to go. Again, those decisions are per table basis. What are we going to call it? What are the attributes going to be? What's the primary key? All right. Fabulous. I'll continue in a moment.